And welcome back. We are on to Module 5, and we are talking about, in this recording, we are discussing Chapters 8 and 9. And actually, we're not going to do a lot of discussing of Chapter 9. That's mostly conceptual, and the numbers that are in Chapter 9 essentially represent an extension of the budgeting chapter, which we covered in our past module. On the other hand, Chapter 8 is actually very different. Variance analysis is a new and different topic. And so I'm going to spend this recording, or dedicate this recording, to talking about Chapter 8. It will also interest you to know that with you in this recording, I am going to reveal an error in the textbook. Is that possible? Indeed it is, and it is self-evident. I will also chat with you about how one should prepare oneself to find such errors right off the bat by taking an initial step that the textbook does not recommend. Does that mean that the textbook made the error because it did not take this initial step? Maybe it's not attributable to the failure to take the step. However, if the textbook authors had taken this step, they would have found their error early on. Okay, so what is this error? And what is variance analysis all about? Let's go to Chapter 8, specifically look at section or subsection 8.2 and 8.3, which represent computations of materials variances and labor variances. Now, each of these sections, 8.2 and 8.3, have within them a summary problem called your turn. We've seen many of those your turn problem sets in previous chapters. I happen to prefer, for purposes of explanation, the 8.3 example, because I believe that the numbers are a little bit simpler to work with, but this could just as easily apply to the 8.2 example. And let me say as a side comment that even though I will take you to the error in the your turn problem in subsection 8.3, if you were to go back to the your turn problem in 8.2, you would find an error as well. But let's look at 8.3, and again, it's within that pair of 8.2 and 8.3, but 8.3 involves labor variances. The your turn problem is, I guess it appears a little bit below figure 8.4. There's a couple of paragraphs. Below 8.4, there's a chart. There's a couple more lines, and then you find your turn. Okay, what's this problem, the your turn problem of section 8.3, all about? Well, you have a company, and the company actually pays its workers by the hour. But the rate that it pays varies. Now, that's not that unusual. Maybe the company is hiring workers from an agency, and the agency might pay a going rate that's based on a market number that fluctuates daily. In any event, the company, if you look at this problem, actually ends up spending $35.35 as an hourly rate to pay its employees. it actually pays those employees by the hour for 16,000 hours. Those numbers appear in the upper left-hand box of the chart. Are these good numbers or bad numbers? Well, it depends. If you look at the upper right-hand box of the chart, the standard or budget or original expectation was that the company would only pay $35 an hour. That's lower than $35.35 per hour. The expectation was also that the company would originally expect to use 16,500 hours, which is more than 16,000 hours. So, did the company do better or worse than expected? Once again, it depends. It's actually a little bit of both. The company expected to pay a wage per hour of $35. It actually paid more, $35.35. So in terms of how much they were paying per hour, they actually did worse than originally expected. On the other hand, the company originally expected to have to pay for 16,500 hours. They actually only needed, and thus only paid for, 16,000 hours. And so in terms of the number of hours they paid for, they actually did better than expected. Worse than expected on the rate, better than expected on the number of hours paid for. So overall, are they better off or worse off? Well, here's where the textbook authors do not recommend that you do something that I believe you should do. I would initially say, before getting into the details of this problem, hey, if I originally expected to use 16,500 hours, and if I originally expected to pay $35 an hour, then my original budget expectation, my standard, if you will, would have been set at 16,500 hours times $35 per hour. I would have originally expected to pay in total $577. Well, let me be more specific. $577,500. If you look at the box in the upper right-hand corner, 16,500 hours times $35 an hour, I would do that multiplication. Do you see that little X in the middle of that box? You're expected to do that multiplication. And by doing that multiplication, you would come up with an original budget or standard expectation that you would need to spend in total $577,500. Then I would go to the upper left-hand corner and I would say, okay, I originally expected to spend $577,500. What did I end up actually spending? Well, according to the box in the upper left-hand corner, I actually spent 16,000 hours times $35.35. That product, the total amount I actually spent, works out to be $565,600. Let me say that again. 16,000 times $35.35 equals $565,600. And so I would have said, my original budget expectation prompted me to expect to spend $577,500. I actually spent less than that in total. I actually spent $565,600. Thus, I underspent my budget. By how much? $577,500 minus $565,600. I underspent my budget. I came in under budget by $11,900. Well, when you underspend your budget, when you come in under budget, that's a good thing. And therefore, we would say the total variance from our original budget was $11,900 favorable. And that's where the error comes in. If you look at the box at the bottom of this your turn picture, it says that in total, you varied from your original budget by $11,900 in an unfavorable way. But you didn't vary in an unfavorable way. You varied in a favorable way because you underspent your budget. The word unfavorable should say favorable. And if the authors had recommended that you begin, as I just did, by computing the product of the numbers in the upper left-hand box and the upper right-hand box, you would have come up with that dollar amount and that favorable, not unfavorable, but favorable conclusion right off the bat. Now, what is the rest of this all about? Well, that bottom box tells you how much you over or underspent your budget by. And again, as we just computed, you actually underspent your budget by $11,900, which should be considered favorable. The two boxes in the middle are designed to tell you why the number is a favorable $11,900. The middle row box on the left says, hey, look, you used 16,000 hours. However, you overpaid your original budget by 35 cents an hour. 35 cents an hour times 16,000 hours is $5,600. And so we can conclude that the fact that you overspent that $35 rate by 35 cents an hour gave you, in terms of its total impact, a $5,600 additional bill to pay. And that's a bad thing. That's unfavorable. Now, let's look at the middle row box on the right. That is saying, look, you originally expected to pay $35 an hour. The good news, though, is that you didn't use or pay for 16,500 hours. You actually used and paid for only 16,000 hours. That had a beneficial financial impact. Of how much? Well, you used 500 hours less than you originally thought you would. And 500 hours times 35 bucks an hour equals 17,500 bucks. In other words, the fact that you used fewer hours than you thought you would had a favorable $17,500 impact on your pocketbook, on your cash balance or cash position. Finally, and this is a different way to find the same textbook error. If you look at the two boxes in the middle row, the box on the left says you paid more per hour than you thought you would, and that hurt you to the tune of $5,600. The box on the right says, yeah, but on the other hand, you used 500 fewer hours than you thought you would, and that helped you, that saved you $17,500. Well, if that first impact was unfavorable, it hurt you by $5,600. And if that second impact was favorable, it helped you by $17,500. If you have two different impacts, a $5,600 hurt and a $17,500 help, if you net those two against each other, they net out to a net benefit or net help or favorable variance of $11,900. The bottom line is the middle boxes, that middle row, is correct. The top row of three boxes, that is also correct. The number in that bottom box on the third row is the net impact of a $5,600 negative impact and a $17,500 positive impact. Those two impacts netted together equals $11,900 favorable. And that's another way to come up with the conclusion that you had a total labor variance that was favorable to the tune of $11,900. Okay, so what did we learn? The point of variance analysis is to begin by saying, what did I expect to spend originally? That is my standard. What did I actually wind up spending? That's how much money came out of my cash account. That's how much I paid. If I paid less than expected, that is favorable. If I paid more than expected, that is unfavorable. But you don't stop there, because there are two reasons why you might have overspent or underspent. One is you might have used more or less product or items, or in this case, hours, than you originally expected. And the other reason is, for each of those hours or products or items, in this case hours, you might have paid a higher rate than expected per hour or lower rate per hour. So if you overspent or underspent your original budget in total, you want to compute the numbers in that middle row of boxes to try to figure out how much of that difference is due to a variance in the number of hours used, and how much alternatively was due to the rate per hour that I spent. Hope you found this helpful. This may well be the final completely new and different quantitative activity of the course. Yes, we do have a few more chapters to go, but I believe that you might find them more conceptual than quantitative, and they do build on the budget processes and other processes that we've already reviewed earlier in the course. Thank you very much for joining me in this module, and I look forward to seeing you, or hearing you, or speaking to you in the next one.